Okay, so here's the next thing we encountered this week, this is what I gave you to review a little bit about learning about E. So our friend Nassim Taleb was talking about something else. This wasn't his main point, but what came up in the discussion was the difference between 1.01 to the 365 and E to the 365 over 100. So let me not forget to zoom out here. So 1.01, actually, you want to do these out on the scientific calculator? 1.01 to the 365 is something in E to the 365 divided by 100, or E to the 3.65 if you prefer.
So 1.01 to the 365.
Let's call it 37.78. And what is E to the 3.65?
E to 365 over 100, so 3.6.
Yeah, 3.65. Yeah.
38.47.
38.47. So it's kind of, well, maybe it's a coincidence, or maybe it's not a coincidence that these two numbers that Nassim was talking about do end up being pretty close together. And so what's going on here?
So this kind of shows you that E is close, or E to a small power is close to 1 plus that small power when that power is small. That's what we have here with the 1/100th. So I guess you could sort of see this if you wanted to look at the Taylor series approximation for e to the x.
Okay.
Or at 0. I think it's called something different at 0, but
Well, it's called the Maclaurin series.
yeah. So e to the x at 0 is 1, or e to the 0 over 0 factorial, plus x over 1 factorial, plus x squared over 2 factorial, plus dot 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 dot.
Okay.
So when x is small, we can just approximate it with this.
All right.
And pretty much anything past here is negligibly small.
Okay. So what is x here? What is the small value?
So x is 1/100th. So this is saying e to the 1/100th, 0.01, equals 1 plus 0.01.
Yeah, may as well, just to be precise, say approximately.
Yeah.
Okay. All right. So we know from calculus that if x is small, if absolute value of x is small, less than 1, e to the x is approximately 1 plus x. Okay. So how does that help us understand these two things?
Well, so we can, if we just rewrite this, we can write it as e to the 1/100th, and then quantity to the 365, because
Okay. Go ahead.
So
You're
e,
not writing through the.
e to the 0.1 to the 365,
Uh-huh.
since powers will multiply when they're powers of powers. We can say this is because we know that e to the 0.1 is roughly 1 plus 0.1,
Mhm.
is approximately equal to 1.01 365, which is why these are so close.
Yeah, and actually you can even, from your approximation, you can even understand why this one needed to be a little bit larger.
Yeah, because you have the extra x squared over 2 factorial, x cubed over 3 factorial.
So it is a good approximation, but you know even more than that. It's not just a random approximation. It's a little bit less.
Yeah.
So that's good, and in fact, this generalizes to actually a different definition of E. We can say that the E is defined to be the limit as h goes to 0 of 1 plus h to the 1 over h. Make sure that doesn't look like an n. So in other words, if h was 0.01 here,
Mm-hmm.
E would, it's not it's not going to 0 yet, but we would say E is approximately 1.01, and what would 1 over H be here if H was 0.01? 1 over H would be
100.
100. Do you know what E is? To a couple decimal places?
2.7.
Maybe 2.71828.
Yeah, so E, which is approximately 2.718. Sorry, running through the tripod is. Why don't we go to the scientific calculator one more time, and why don't you compute 1.01 to the 100th power?
1 to 100. It's about 2.70.
Yeah, so it's actually pretty close.
Yeah.
And so that is, in fact, another way we could look at this from this definition of E.
Mm-hmm.
By the way, it's an interesting exercise and a difficult exercise to prove that this definition of E and the other definition of E, the sum of the inverse factorials, are the same definition, but they are actually.
Yeah.
Right.
We could say that this 1.01 to the 365 is 1.01 to the 100th to the 365 over 100.
Yeah.
And so do you see why these two things ought to be near each other again?
Yeah, so this is roughly E, and then that gives you this equation.
Okay. So it's cool. So this is, E comes in, well, I guess E showed up 3 times this week in 3 different settings. This is setting number 2. All right, let's go to setting number 3.